What it do, E-World? Crisscrossing wires, and while I'm working on this little teeny pack right here, I want to discuss a few battery facts and misconceptions people seem to have about e-bike batteries and BMSs and just other little stuff that needs to be said so people understand. First of all, people seem to think that a battery with no BMS will not be able to balance itself. That is false. For one thing, BMSs do not balance batteries, okay? BMSs basically monitor batteries. Alright, they monitor each stage of the battery, each S stage as far as the series groups and the parallel groups. It monitors the voltages in those stages, and BMS has the capability to shut charging down and discharging down. If for some reason one of those stages voltages is way off of what it should be, that's all a BMS does, okay? Let's say if you're charging a battery, all right, and one particular cell group is not charging, like the 4S stage, because let me okay, here's some BMS wires. All right, when a BMS is wired to a battery, each one of these little wires goes to each stage, 1S, 2S, 3S, 4S, on up, depending on how big the battery is. Each one of these little wires is soldered on to that particular stage, and it's reading that voltage for that entire parallel group, okay? That's all that wire is doing. That wire has nothing to do with balancing cells or any of that, okay? That wire is getting a signal, sending that signal to the BMS, letting that BMS know that that 4S stage battery voltage is 3.5, 3.7, whatever it is, okay? It's monitoring the voltage for that stage, all right? Batteries balance themselves when they are in parallel, okay? If you take this group of batteries right here, here's 6 batteries, all right? 6 batteries. Let's say all of these batteries had different voltages, not way off, but you know, a couple hundredths of a volt off. Say this one was 3.74, this one was 3.78, this one was 3.72, 3.75, all right? All different voltages. Once you put them in parallel, connect all the negatives, because this is the negative side. Once you connect all the negatives and all the positives together, once they're put in parallel, they will balance themselves as far as the voltages, all right? Whatever the highest voltage battery is in this group, start trickling current off to whatever cell in this group has the lowest voltage. You know, current will start flowing through these batteries once they're connected in parallel and in the circuit, all right? They will balance themselves out, okay? Now, what you don't want to do is put batteries in parallel if their voltages are significantly different. Let's say like this battery was 4.2 fully charged, and this battery down here was 3.1 volts, almost dead, All right, you know, well, dead far as shut off voltage, low voltage cutoff. All right, if you were to put them in parallel, then a significant amount of current would start flowing from the batteries that are charged to the batteries that are discharged. All right, and you know that current would flow until the battery voltages leveled out. Okay, they would level out at some point. And like I said, there would be significant amount of current flow. Now, you would, you know, these can be parallel without even being connected to a circuit. Like I said, connecting all the positives and all the negatives. Once you did that, these cells would balance out. No matter what their voltages are, after a period of time, once you put your voltmeter on and read them, they will all be the same voltage after, you know, however long that takes. It wouldn't take long because these are high current cells. Like I said, a lot of current would flow immediately and they would level off. Now, depending on how much current was flowing, they would heat up a little bit because there's a lot of current flow. However, nothing bad could actually happen in that case. It just would be a lot of current flow. Now, depending upon, as long as all the cells are good. Now, if there's a bad cell in this group, bad meaning shorted, because a cell can be bad two ways. It can be dead shorted, which is going to read 0 ohms when you read it with an ohm meter as a dead short, or it can be open infinite. If the cell is open and infinite, when you connect it in parallel, it's not going to have any effect on the rest of the batteries because it's like it's not even there. When it's open means there is no complete connection through that cell. You know, if you go to read that cell voltage, it would be no voltage because, like I said, the cell is open. If it were dead shorted and it was in parallel with other cells that have current, then that would be a bad thing. A dead short would be a crucial amount of current flow, and depending on how much these other batteries are charged, if they're fully charged, that could definitely cause a fire or something would burn up. Most likely the nickel strips or whatever you have them that's connecting, whatever material you're using would burn up. If you have a heavy enough gauge wire on these batteries, putting them in parallel, the wire would not burn up and the cell would most likely go into thermal runaway. Like if you had a big thick 4-gauge wire across these cells, obviously that wire is not going to burn up. That cell is going to burn up. Okay, so cells will balance themselves. BMSs do not balance the cells. Okay, now you can get a charger that is called a balanced charger, like this charger right here. This charger, when connected to a LiPo battery, the main positive and negative goes in there. That's what's actually charging the battery. On the sides here, you see where the balance lead, they have different sizes depending on which type of LiPo you're using. But as you see on these LiPo batteries, there's 2 batteries in this pack. This is the balance lead right here. Basically, that's like the leads to a BMS. Each one of these wires goes to, these cells are 3S, okay? Each one of these wires goes to a stage in those cells, just like I was telling you, 1S, 2S, 3S. All right, now, when this pack is connected to this balance charger is reading the voltage at each one of those stages. So this charger will balance a pack, because if the 2S stage voltage is different from the 3S stage, it's going to allow more current to flow to that particular stage until they even out, and then they're all going to be even. It's going to keep charging the pack until they all get fully charged. This is a balanced charger. It will read each stage. Now, that is this balancing the batteries, but not the BMS. BMS, all a BMS does is basically monitor a pack. All right, that's what BMSs do. They monitor the pack and they turn off either the input charge side or the discharge side. Like if you have BMS connected to your discharge side, and whatever you're running, your controller is pulling more amps than that BMS is rated to handle. Like say you have a 150 amp BMS and you have a 400 amp controller on your bike, and you have it turned all the way up where it's drawing 400 amps, the BMS is going to read that it's trying to pull 400 amps, and it's going to shut off, it's going to trip, it's going to shut off the discharge side and shut your bike off. All right, now most BMSs will reset after you power off and power back on. It will have power again, but that's what it does. It monitors the charge side and discharge side. Now, same thing with charging. If you're charging a battery and the BMS is reading the voltages, when if for some reason you were charging with the wrong charger, let's say you had a 60 volt charger and they had XT90s on it, so you didn't know, you plugged a 60 volt charger up to a 52 volt battery. Once it got to the full charge of a 52 volt battery, I think it's 58.8 volts. Once it got to 58.8 volts, actually a little over that, once it started trying to go over that voltage, the BMS would trip on the charge side and would open and stop the current flow and basically protect that battery from overcharging. That is what BMSs do. They protect from too much charge and from too much discharge, but they do not balance packs out. These leads going to each section aren't balancing the pack. They're just reading the voltage at each stage, okay? That is a misconception people have. I was reading in the comments on somebody's video, and because they didn't have a BMS, people were like, how come, how do the cells balance? No, that doesn't balance cells. Cells balance once they're in parallel. They will all level each other out just because they're in parallel. That physical connection alone. All right, so that is a misconception. Another misconception about batteries. I was talking to somebody the other day, and I was talking about voltage sag, and telling them that packs had to be constructed properly to be able to transfer a large amount of current. Just because you had monocells in this pack doesn't mean that this battery is going to produce a lot of amps because they're monocells. If these bus bars aren't thick and wide enough for high current, it's not going to allow the maximum current flow, and you won't get maximum amps from that pack. And you will experience voltage sag. They were saying, the only reason the pack is sagging is because the cells can't handle it. Yes, true. Voltage sag do come from cells not having enough discharge current, But at the same time, you can also get voltage sag from the conductive materials not being able to allow that amount of current flow. Not even the battery pack alone, the power leads. If your power wires aren't heavy enough gauge, if you have 10 gauge power wires on a big pack and you attempted to pull 600 amps through some 10 gauge wires, you would experience a lot of voltage sag because it's going to be high resistance. So that current is, you're not going to get maximum current flow, so there's going to be a voltage drop. At the same time, that's if it's not enough amps to burn up those wires. You know, at some point, trying to pull more amps than the wires can handle, they will burn up just like a fuse element. You know, but depending on how long you try to, you know, it takes a minute for that to happen, unless it's an instant rush of a crazy amount of current. But if not, if it's just a little more than those wires can handle, they're going to be heating up. It would take a while for them to burn up, but you would experience a lot of voltage sag due to the voltage drop across those wires. So, not just the cells, but how the pack is constructed. That's why I always talk about when you're building a pack, how it's built, your series parallel connections. You can't build a battery in series where there's only one path for current to flow, and depending on the thickness of materials you're using, if they can't handle the amount of current flow. Alright, so yes, there's reasons why that is. Alright, so that's it. I probably repeated myself a lot, but like I said, these aren't scripted. I'm just talking off the dome, and I'm just, you know, like I said, I wanted to clear up some misconceptions that weren't true. And I didn't do any work because I was running my mouth. But that's why I say a lot of times I don't want to film and do and work, because when I'm talking, I don't get my work done. So anyway, later, BMS Facts.